All right, so you guys should understand the metabolic acidosis problem. So the first thing is you have a metabolic acidosis and you ended up having a anion gap. So with the anion gap, I said that there could be two other contributing reasons, and you could have an acidosis on top of it, or you can have a metabolic alkalosis on top of that. So now, what I'm going to be going over in this video is I'm going to be going over the jargon, and the values. So I'm going to talk over the terms and the values, and then since you know the basic concepts, these terms and values should be easy to understand. So initially, we had anions, and as I said before, we have our fixed acids, and we have a bicarb, and then we have our chloride. So let's go over the values. So first thing is your fixed acids. Your normal value of fixed acids is 12. So it's actually a range. It's a range between 8 and 16, but when you kind of find the number in between, it's going to be 12. So 12 is going to be your normal fixed acids. It just makes things easier to work with. So you'll have to trust me on that one for now. So the next thing you want to know is that your bicarb is going to be in the ranges of 22 to 28. And how I remembered it is because I kind of used 1, 2, 2, 2, 2, 8 like that. And you know that's 12, 22, 28. I mean, it just like there's 6 numbers and you only memorize 3. So I figured that it was a good way of remembering this little pathway. So you should be able to draw 12, 22, 28 like that. It'll help you solve these questions without using any equations or anything like that, just visual, completely visual. So, all right, so now that's the first thing. So we have our anions, we have our fixed acids, we have a bicarb, and we have your chloride. So let's talk about the first metabolic acidosis that we had. The first metabolic acidosis we had was in terms with the anion gap. So first thing is when you have an increased amount of fixed acids, the fixed acids, as I said and explained to you in the last video, was that the fixed acids would eat up your bicarb because the limitations of the hydrogen pump. So when it eats it up, you want to look at 2 spaces. The first space I'm going to bring you attention to is this space over here. This space is going to be your bicarb. So your bicarb is less than it should be, which is what pretty much told you in the first place that it was a metabolic acidosis. Now the next space over here is the amount of anions that that ate up, the amount of fixed acids that ate up your bicarb. So this one over here is called your delta gap. So in the ideal world, when you only have a metabolic acidosis with an anion gap, then technically look at the space. The space is supposed to be, this space over here is supposed to be 22 and 28. So if you added your anion gap with your current HCO3, your bicarb, then your delta gap plus your HCO3 should equal 22 and 28. So in the ideal case, when you only have an anion gap metabolic acidosis with no other problem, it should be 22 and 28. So this value has its own name too. This is actually called the delta-delta. So those are your 2 terms. Your delta gap is that little space that your fixed acids had eaten up from your bicarb. And your delta-delta is the space, and this can change, the space that your anions and your bicarb is taking up. But as I said before, your bicarb can be affected by other things. It can go up or down. So let's talk about that. So you have the two situations. You have your two situations. You already have a fixed acid that is eating up your bicarb. And now the next thing we need to talk about is what would happen if you had another problem on top of that. So like, let's say, as I said before, hypoaldosteronism. So that will be giving acidosis, another metabolic acidosis. What would you expect to see on this? If you had another acidosis, then the amount of bicarb you have would be less than you expect. So if it's less than you expect, this is eating up your bicarb too. So now the amount of bicarb you have is this much. So if this is the case, let's take a look. This is your delta gap. This area over here, up to here, is your delta delta. So if you compare your delta delta with the normal amount of bicarb that you have, do you have less than you expect or more than you expect? Well, if the delta delta has less area than this 22 and 28, which should be up to over here, then that would mean that you have some sort of metabolic acidosis on top of your initial metabolic acidosis. So on the other hand, let's take a look at the other example. In the other example, let's say that you're going the opposite direction. What if let me make this another color. Let's do this. Your bicarb is greater than you expect. So if it's greater than you expect, the area is this big. What would cause you to have more bicarb? Well, vomiting would, and acids would. So in this case, your area over here and over here, so remember this is your delta gap over here, but when you take your delta gap and then you take your bicarb over here, that will be your delta delta. Is your delta gap, this bar over here, bigger or smaller than this bar over here? This is the normal range. The normal range is this much. It's 22 and 28. Is it bigger or smaller? It's bigger. That would have to mean that you have a metabolic alkalosis. All right, so those are the values, and now I'm going to go over a question on how to solve these. So this is the question. This is in your notes, but I'm going to walk you through this. So the first thing we want to look at is that the pH is 22 to 28, so 7.22. 7.22. This is going to be acidosis. So as with any acid-base problem, what you would first do is it is an acidosis. So now the first question is it metabolic acidosis? So is it metabolic acidosis? It should be between 22 and 28, right? If it should be 22 and 28, then this is definitely a metabolic acidosis. Let's take a look at your PCO2. Your PCO2, this seems a little bit low. So if this is a little low, then we have a... Okay, first thing you have to ask, is it a respiratory acidosis? So is it a respiratory acidosis? Respiratory acidosis would mean that the CO2 would be higher than expected. This is lower than expected, so it cannot be a respiratory acidosis. This must be some sort of compensation. So this is respiratory compensation. Now, the next thing we have to do is, if this is a metabolic acidosis, is there an ion gap? So in order to figure that out, I always draw this out, and it just makes it really easy for me to see. This is going to be your fixed acids, your bicarb. I don't like to memorize anything. I just like to see things conceptually. So we want to find out your anion gap. This is your anion gap. How do you solve it? Well, you have the big one over here. You have the big sodium. Subtract this. So you have your sodium, 131, minus your bicarb over here, which is 12, plus your chloride over here, 90. So that's going to be 102, 131. So 131 minus 102 is going to be 29. All right, 29. So this is going to be 29. All right. So now that's the first part. This is everything that you've done so far already. Now the next part is to figure out whether there's a secondary metabolic acidosis or secondary metabolic alkalosis. So this is the method. So the first thing you're going to do is you're going to draw this little box. You're going to draw a fixed acid box. You're going to draw a bicarb box, and you're going to draw a chloride box like that. And then you have to give me some numbers. So the numbers normally is going to be 12, 22, 28. Draw that first. That's the first thing you draw. All right, so the first one is draw the setup. The second thing you want to do is to take a look at your anion gap. How much was eaten? So I say eaten because it's like when you have anions, it eats up your bicarb. It eats up the ability to reabsorb bicarb. So like if you have 29 and your normal is supposed to be 12, then obviously this one eats up some of the bicarb over here. And then this whole entire thing should equals 29. So what is this area over here? What is this area over here? Remember what that area was? That was called your delta gap. So let's figure out your delta gap. 29 minus 12. 29 minus 12, 17. So that's how much you're eating up. That's the first part. Now, the second part is to look at this line over here, this line over here. This line, did it go this way or does it go this way? So the only way that you can figure out is if you looked at your question again, and then you looked at the amount of bicarb that you have. So let's take a look. Your bicarb is 12. So now, then you can calculate your delta-delta, which is this with this. So let's take a look. Your delta gap was 17. Your bicarb was 12. What is that? It's 29. 29 is this area. If this area was 29, then that would mean that this whole entire line has shifted down. Why? Well, because this area should be 28, 22 to 28. 22 to 28 is just here to here, which is what you initially drew. But since it's 29, it means that this bicarb had shifted down, and now it's taking more space than it really should have been. So in that case, that means that you have a metabolic alkalosis on top of your initial metabolic acidosis with anion gap. So you have metabolic acidosis with a metabolic alkalosis. So quick recap. So first, draw the setup. The setup is this: fixed acids, bicarb, chloride. Draw your setup. 12, 22, 28. How much bicarb was eaten by your fixed acids. That's your delta gap. And then finally, add patient HCO3 to see whether this line had increased or decreased. After that, that's basically your delta delta. That's your delta delta. Delta delta is this over here. I mean, it depends on where it ended up being. If it got smaller, then your delta delta would be smaller. If it's bigger, then your delta delta would be bigger. So now with that delta delta, you compare it to that number. Is it less than you expect? If it's less than you expect, then you have another metabolic acidosis. If it's more than you expect, then you have a metabolic alkalosis. And in all these cases, remember, it's with the initial metabolic acidosis with the Anion Gap. And that's it. I know it's a really hard subject to go over. I hope that you find it useful.